So, this video is about my compilation of activities here in chapter 7. So, watch this. So, let's start. We will launch course and then we will find the chapter 7. So, we will find the first activity here in chapter 7. So, let's So the first activity was here on page 7.1.1.5, and this activity was entitled as the binary to decimal conversion. So the instruction is, this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So we will add all numbers in position that has a number that has a bit, which is 1. So we will add the 128 plus 64, and it is equals to 192 plus 32. 192 plus 32 is equals to 224, and then we will add the 2 to 224 plus 2 is equals to 226 plus 1 is equals to 227. So let's check it's all correct, and we will try a new number. So we will add 128 plus the 32 is equals to 160 plus the number 2. So 160 plus 2 is equals to 162 plus 1 is equals to 163. So we will put in decimal value the 163. So it's correct. So now we will proceed on the next activity, and the next activity was here on page 7.1.1.8, and this is entitled as the decimal to binary conversion utility. So this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversions without error. Convert the decimal number shown in the decimal value row to its binary bits. So we have a decimal value that is 141. So we will start in 128. 128 is less than 141. So 141 minus 128 is equals to 13. So we will put 1 in bits for 128. So we only have a 13. So 64 is greater than 13, so we will put 0. 32 is greater than 13, so we'll put another 0. 16 is greater than 13, and we will put 0 again. And 8 is less than 13, so we will put 1. Then 13 minus 8 is equals to 5. So 4 is less than 5, so we will put 1 here. And so 5 minus 4 is equals to 1, and 2 is greater than 1, so we will put 0, and we will put 1 here in 1. So we will check. So it's all total in 141. So next, we will find the next activity here. So the next activity was here in page 7124. So this activity was entitled as the ending to determine the network address. Use the ending process to determine the network address in binary and decimal formats. So ending, we will add the host address in binary and the subnet mask in binary. So we will copy the we will only copy the numbers that has a all 1. I mean is when the host address is 1 and the subnet mask in binary is 1, we will copy it. But if the other is 0, we will not copy. We will put 0. So 1 and 1 is equals to 1, and 0 and 1 is equals to 0. 1 and 1 is equals to 1. 0 and 1 is equals to 0. 1 and 1 is 1. 1 and 1 is 1. 0 and 1 is 0. 0 and 1 is 0. So next, 0 and 1 is 0. 0 and 1 is 0. 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is 1. 1 and 1, 1. 0 and 1 is 0. So next, as you can see, the subnet mask in this 8-bit is all 0. So it means that it is all 0. And another is it is the subnet mask. The subnet mask is all 0. So we will put all zeros. So now network address in decimal. We will add all ones here. So as you remember on the last activity, it has 8 bits. So we will start on left. So it is 128 plus 64, 32, 16, 18. I mean is 8, 4, 2, and 1. So we will add the 128 because it has 1, and then 64, which is 0, so we will not add it, plus 32. So 128 plus 32 is equals to 160, plus 16, I mean is next is 16 is 0, so we will proceed on 8. So 160 plus 8 is equals to 168, and then next is 4. So 168 plus 4 is equals to 172. And as you can see, there is no another 1. So we will put 172. So next, it is 0, 0. So 128 is 0. 64, 32 is 0. So 16. 16 plus 4 plus 2 is equals to 22. So we will put 22 here. And it is all 0, so it means that is 0 and 0. So let's check. It's all correct. So now we will proceed on the next activity. So the next activity was here on page 7.1.3.7. So this activity was entitled as the Unicast Broadcast and Multicast. Click Start to view the destination IP address. Next, click the host, which will receive a packet based on the address type, Unicast, Broadcast, or Multicast. This is a time activity, so the time remaining is 10. If we click Start, we will look for the destination IP address. And these are the source host, so we will click Start, and the destination IP address is 192.168, so we will find it. So as you can see, it is 255, so we will click all and we will wait for. So you have successfully identified the transmission type. We click all the computers here, group. So another, we will 192.168.105, so we will find 5, and it has the only one computer here. So it is successful. So we will proceed on the next activity. And the next activity was here on page 7.1.4.2, and this activity was entitled as Pass or Block IPv4 addresses. Decide to pass or block each IP address depending on whether it is public, the internet or private small local network, click start to begin and click on either pass or block. So we will pass if it is a public internet. So we will click start and then 190, so we will pass it. We will pass. So pass again. It's block. Oh, it's wrong. So 150 is pass. We will block it and pass. So we earn 10 points. So next we will proceed on the next activity, and it is located on page 7.1.4.8. So here, public or private IPv4 address. Drag each IP address to the correct category, public or private. So 172.16.35.2 is a private. So 192.168.3.5 is also a private. 192.0.3.15 is a public. And 64.104.0.22 is a public. 209.165.201.30 is a public. So 192.168.11.5 is a private. So 172.16 from 172.16.30.30 is a private, and also it is a private. So it's all correct. So we will proceed on the next activity. So the next activity was entitled as the IPv4 issues and solutions, and it is located on 7.2.1 page. So drag the IPv4 and IPv6 terms to the field next to the appropriate description. So first, 128-bit address and the 340 undecillion addresses is the IPv6. Next is the 32-bit address, which is the 4.3 billion addresses, is the IPv4. Transport an IPv6 packet over the IPv4 networks is the tunneling. Next is uses NAT64 to convert between the IPv6 and IPv4 is the translation. Next is allows IPv4 and IPv6 to coexist on the same network segment, which is the dual stop. So let's check. So now we will proceed on the next activity. And the next activity is located on page 7.2.2.4. So practicing the IPv6 address representations. Convert the IPv6 addresses into short or omit the leading zeros and compressed forms. Use the numbers at the bottom of the page to continue this activity. So omit leading zeros, so we will copy. So zero, if is all zeros, and we will put 0. So it is start with 0 and we will not copy the 0. We'll start on DB8. Next, it is all 1. So we will copy this. And next is all 0. So it is 0. Another 0 and 0 and 200. So we will compress format. To compress it, we will copy this to 2001 colon 0 colon and DB8 1111 and then we will put 2 colon because it has 3 zeros and 200. So let's check. Next is another conversion. So 213, and the next is 0. Next is 123, and 4 5 6 7 8 9 AB, the C D E F, and the 0 and 1. So we will compress it. We will copy and separate them with the colon. Then C D E F, then 2 colon, then 1. So check. It's correct. And number 3, conversion. It's all zeros except on the last. So we'll put 0 here and only 1. And then we will put in compressed format is 2 it's 2 colon and then 1, and check it. So next is 2012. Next is ABCD, the EF01, EF01, 2345, the 678, then 910, AAAA, and BBBB. So we will compress it. Then 6, 7, 8, 9, 10, then AAAA, and BBBB. So as you can see, we did not use the 2 colon because it has no zeros in between. So 5, conversion. AB1E, 2B00, 0, 1, 2, 3, 4, 5, 6, 7, 8, the 9, 1, 0, 1, 1, 1, 1, 2, and 1, 1, 1, 3. So copy them. 2B00 and 2 colon, and then we will skip the 0, and it represents the 2 colons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, and 1, 1, 1, 2, and 1, 1, 1, 3. So next, number 6, BB2B, EF12, BFF3, 9125, 1111, 101, and then 1111 and 101. So compress it. BB2B colon, EF12 colon, BFF3 colon, 9125 colon, and 1111 colon, and 101, 1111 colon, and 101. So next, 7. Copy them again. 1984, 2233, 4455, 667, 0, 0, and 101. So compress it. 1129, 1984, 2233, 4455, 6677, and then 2 colon, and then 101. So check. Number 8, 1111, 0, 0, 0, 0, 0 again, and 101 1111. So we will compress it. 1111, then 2 colon, and then 101 and 1111. So we'll proceed on 9. So number 9. 1031 to 1976, and then 1 2 3 4 0 and 101. So compress it. 10 3 1 1976 1 2 3 4, then 2 colon and 101. So let's check. Next is 10, the last one. Then 0 0 0 1 2 3 4 6 6 7 8 9 1 0 1 0 and 3 4 AV. So we will copy this. 2 colon, then 1 2 3 4. So check. It's all correct. And we will proceed on the next activity. The next activity is here on page 7.2.3.5. And this was entitled as the Identify Types of IPv6 Addresses. Drag the IPv6 address type to the most appropriate description. So, unique, internet routable IPv6 address, dynamic or static. It is the global, Unicast, FE80, 2 colon and 1 is a link local. The 2001 colon DB8 colon ACAD, 2 colon and 1 with a prefix of 64 is global Unicast. So typical IPv6 prefix used to indicate the network portion of the address, so it is the /64. Used to communicate with other devices on the same IPv6 subnet is the link local. So let's check. So now we will proceed on the next activity. So it is located here on page 7.2.4.8, verifying IPv6 address configuration. So we will configure what is needed here. So enter the show command that will display a brief summary of the IPv6 interface status. So to show it, show IPv6 interface brief, then enter. So next, enter the show command that will display the IPv6 routing table. So we will type the show IPv6 route, then enter. So verify connectivity to PC2 at 2001 colon DB8 colon ACAD colon 1 double colon 10. So we will put ping, then copy this 2001 DB8 colon ACAD double colon, is 1 double colon and 10. So enter. So that's all. You successfully verified that the IPv6 address configuration. So we will find if there is activity here. So that's all, and we will return to class. So that's all, and thank you for watching this video. I hope you learned from this, and I'm Kisha Lyka Villanueva of IT 2105.